Okay, so I'm going to graph on here. We're going to graph secant to start. I would highly recommend to choose some colors so that you can have one color for the reciprocal function and then one color for the other one. So I'm going to do cosine in blue, and then my secant function will be in red at the end. Okay. Quick reminder, what is secant the reciprocal of? Cosine, great, because that's the one that's up there. Wonderful. Reminder, I would just write this as 1 over cosine, so that way we can remember that. And it'll make sense here why our graph looks a certain way once I draw some stuff on here. Okay, so we're going to graph the cosine function to start. Okay, and I think this graph is just one short of going every 2, so I'm just going to go every 1. So I'm going to have pi over 2 to start. Pi, 3 pi over 2, and 2 pi. It's a little hard to see that. Okay, so those are my 5 points, and then they go up to a high of 1 and a low of -1. And for cosine, we start actually on the y-axis at 0, 1, and then goes down 2 pi over 2, 0, down to -1, up to 0, and then up to +1. And I don't think there's a way to make this dashed on explain everything. So I'm going to try my best, but I would highly recommend just putting this as a dashed function because this is not actually the function we're graphing. We're graphing the secant function. So this is just going to help us be able to figure out where our main points go for our secant function. So this is going to be my dashed function of secant. Sorry, cosine. This is cosine. Okay. And then we need to talk about a few things about my secant function. So if I were to evaluate a few points here, if I plugged in 0, okay, as my x value, if I looked at all 5 of these points and plugged it into my function, if I did 1 divided by cosine of 0, cosine of 0, if you think about your unit circle, that's your x value. What's your x value at 0? If I labeled this point right here, that would be the point 1, 0, right? So my x value is actually 1, okay? So my cosine of 0 is 1, so my secant of 0 would be also 1, right? So at 0, my secant of 0 is 1. Okay, if I look at my next one, cosine of pi over 2. If I did 1 over cosine of pi over 2, that means that we're now up here on the y-axis. What's the coordinate point up on the y-axis there? If I was to label this point, 0, 1, which means that my x value is 0, so my cosine of pi over 2 is 0, right? So I'm going to have 1 over 0. What happens in that situation? Undefined, okay? So if we have an undefined thing, if I can't have a value of dividing by 0, what do you think we're going to have on the graph? How do I show what I can't have? How do I think we're going to show my values that I can't have? Okay, whole, that's an idea. An asymptote, okay? We are actually going to draw the asymptote on all the values that are going to give us 0 in the denominator. So again, dashed lines at pi over 2. Where else are we going to have a vertical asymptote at? Or else is cosine equal to 0? 3 pi over 2. Okay. So far our red point there is the only thing that we know is on the graph. So let's check a point in between 0 and pi over 2. Maybe pi over 4. If I look at pi over 4, 1 divided by cosine of pi over 4. Well, what is cosine of pi over 4? If I think about it on the unit circle, cosine of pi over 4 is going to be this value right here. So cosine is my x value. So that gives me square root of 2 over 2, right? So 1 divided by the square root of 2 over 2. And I'm just going to tell you, in the calculator, that would tell you it's about approximately 1.7, or no, I think it's 1.41. Okay, so if I were to plot that point on this graph, pi over 4 is in between 0 and pi over 2, and then up at 1.41 is approximately right there.
Why did it go up more?
Okay. Whereas, let's look at, if I just looked at cosine of pi over 4, and if I plug that into the calculator, I get about 0.71, which should be on this graph here. So that point right there is on your cosine function. So your reciprocal function are actually all of those y values are going to be twice as much as the point that is on the cosine function. So like this point, multiply it by 2, gives me that point. Or if I take 0.71 times by 2, I should get about 1.41, okay? And now if we tested a bunch of different points, what you're going to see is you're actually creating these parabolas at the maximum and the minimum points. So here, you're going to actually have a parabola that's going to approach the vertical asymptote, but it's not actually going to touch the vertical asymptote. And then down at -1, that's our minimum point of our cosine function, we're going to make another parabola down below. Again, if I think about doubling this y value, making it twice as negative, it's going to be further down here. Same over here. If I double this value, it should be down here as well. And then our last one is going to be, this is our maximum point, but we are going to approach that vertical asymptote. Okay, just like with sine and cosine functions continue forever and ever in both directions, right? So what I drew right here is just one period length of the secant function. Only one period length, okay? The period length for all of your 6 trig functions are always going to be just 2 pi, okay? But unless there's some sort of transformation that's occurring to it, this is my parent function, and your period will always be a length of 2 pi. Okay, so period length is 2 pi. But then another note that I want you to write underneath here is, because when we have to write the equation, it gets a little tricky to see. You want 2 full parabolas in order to have a complete period. Okay, so like this half over here, if I put it together with this half, that would make one full period, one full parabola, and then I've got one full parabola down below. Okay, my domain, again, we're continuing this function forever, so the domain of a secant function continues both directions, but there are some values that it cannot be, right? So I need to be able to write that down. On your test and your quiz, you will not actually have to like write the domain down on anything. So if it's a little confusing, that's okay, but what I really want you to be able to understand is that it is not able to be these vertical asymptotes. That's what we're writing down, okay? So your domain is any x values, so all real numbers where x cannot equal, now it's going to get a little mathy here when I write this, x cannot equal pi over 2 plus or minus n times pi, right? Because the distance between, the distance between pi over 2 and 3 pi over 2 is just a distance of pi, right? So I'm saying, okay, I could add pi for infinity, and that's always going to be my vertical asymptotes. Or I can subtract pi from pi over 2 for infinity, and that's always going to be where my vertical asymptotes are, okay? Now, again, a little bit mathy here. I need to specify what n is equal to, because n can't be like 0.5 or 0.2, right? N has to be what kind of numbers? It has to be like whole numbers, or if you remember back to all those different kind of groups of numbers, it's actually going to be an integer, okay? So n has to be an integer. So we can say n, this is real mathy, this means right here belongs in the set. It's like a it's like a C with like a little line in the middle there, kind of connected. So belongs in the set of integers, which I don't know why they picked this, but in math they chose the letter Z to represent integers, but with like a double bar on the Z. So this stands for your integers. Okay, so again, really mathy way of writing it. If you're planning to go into more math things in your future, you will see a lot of this. If you are not, that is okay. You will see it a little bit here and maybe in calc, and that's about it, okay? But all it's saying is that it cannot be pi over 2 plus pi values in increments of that. Okay, and then my range value. My range is going to be all of my y values. So my lowest y value that I could possibly have is negative infinity. And that goes up to what? Negative 1. Can I include negative 1? Yes. And then I'm going to start again at 1 and go up to positive infinity. Alrighty, let's talk cosecant now. Same idea, again, it's just going to be a shifted version of the secant function, right? Because sine and cosine are just shifted of each other. So secant is the reciprocal of sine. So this is 1 divided by sine of theta is equal to your cosecant of theta. Sorry, yeah, no, that's right. So in order to graph the cosecant function, I need to figure out what my sine function is so that I know where I'm going to plot my parabolas at. So let's graph sine of x first. So if I graph my x's and y's for sine of x, actually I didn't even do that for the last one. We don't need to do that. We're good.
Okay, can you please?
Oh, we want to? Okay,
Yes.
Sure.
Can you do it for the other one too?
I can go back and put them up there, yeah. Okay.
Sorry, that's good.
Okay, so my x's and y's for sine, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then for sine, I'm going to start at 0, up to 1, back to 0, down to negative 1, and then back up to 0. So I'm going to start by drawing just sine on the graph. Okay, let's do same kind of colors. I'm going to do blue for sine, and then I'm going to do red for my cosecant. Okay, so I've got 0, pi over 2, pi, 3 pi over 2, and 2 pi. Again, make sure you're labeling your axes and plotting your vertical asymptotes when you need them. Okay, so sine, we're starting at 0, 0. And then let's call this 1 and negative 1. We got my 5 points there. And I'm going to create my dashed line of my sine function. Okay. So now we got to think about where is my denominator, or where is sine of x going to equal 0? If I look at this x-axis, where is my y value equal to 0? At 0. Where else? At pi and at 2 pi. So at those three values, I'm going to have my vertical asymptotes because I can't cross those. I can't have my denominator equal 0. And then when I am graphing my reciprocal function, my cosecant function, we're going to have those parabolas again at where my maximum and minimums are. So my maximum is up here, minimum down there, and then I can go ahead and draw in my parabolas. So period will always again be 2 pi unless there is a shift or a stretch. And again, we want 2 full parabolas. This one's a little bit easier to see for the reciprocal of sine because I get 2 full parabolas. I don't have like a half of one. I do just have 2 full ones. Okay? My domain for this. This is going to be, again, all real numbers. Where x cannot equal technically it started at 0, but then every length of pi, we're adding another vertical asymptote. So how could I write that on the other side of what can x not equal? Pi times n. Where again, n belongs to the set of integers, so it can be any number, positive or negative, but it has to be a whole number. Okay, and then my range values for this one are going to be the exact same, right? The only thing that's going to affect your range is either if there's a vertical shift or if there is an amplitude stretch. Okay, so I'm going from negative infinity to negative 1. Oops, but I'm including negative 1. And then I'm going from 1 to infinity. Okay, so now we're going to do some transformations. These graphs, again, the transformations are exactly the same from cosine and sine, except we're doing the reciprocal. So we're looking at those parabolas pieces of the maximum and minimum points, okay? But I would always recommend graphing your reciprocal function first as the guide, kind of as that dashed line. So if I look at this first example here, I've got secant is my function. So what's the reciprocal of secant? Cosine. In case you forgot, they are never going to be C and C, cosine, cosecant. Those don't go together. It's always C and S go together. So double check that you got the right one, okay? So I'm going to graph the cosine function first, the parent function. Okay, so cosine, we're going to apply some transformations to it as well. So I'm going to start out with my x and y chart. I've got 0 pi over 2 pi, 3 pi over 2, and 2 pi. And then if it's cosine, where does cosine start for my y? At 1. So I go 1, 0, negative 1, 0, and 1. Okay, so I've got 2 transformations happening here. What is this 2 doing to my graph? Stretching, right? Yes, so it is the amplitude, and it is stretching my y values. Okay, so we are going to multiply my y values by 2. What is this 1/2 doing to my graph? Yeah, the horizontal stretch, actually. Okay, so my 1/2 is going to affect my period, because period is 2 pi over b. So my period in this case is 2 pi divided by 1/2, because this is my b value. And what is 2 divided by 1/2? 4 pi. Okay, so let's go ahead and multiply that y value by 2. So I get 2, 0, negative 2, 0, and 2. And then since our period was affected, there's 2 ways we can do it. We can either do it visually on the graph, or we can set everything that is in this parentheses equal to all of my x values and solve for those individually. Okay, I think this one's a little bit easier just to do by showing you on the graph. So I'm just going to show you on the graph. We start again with 0 because there was no phase shift. And then we're going all the way to 4 pi. But I still need 5 points there, so that's 2 of them. So it's exactly halfway in between 0 and 4 pi. 2 pi. Halfway in between 0 and 2 pi is pi, and halfway in between 2 pi and 4 pi is 3 pi. Again, if you wanted to solve all of those, you can set your 1/2 x equal to all of your x values. So start with 0 and then go to pi over 2, and you're going to get all of the same values here that I wrote in red. Okay, and then I can just go ahead and plot my y values on there as well. So we're going to go up to a maximum of 2 and then a minimum of -2. So I'm going to plot my points. And then remember, this is only my cosine function, so I'm just going to have this be my dashed lines. Because the function that I actually want to know what it looks like is my cosecant graph. Or sorry, my secant. We're doing secant for this one, not cosecant. Okay. Also, if it said to do this over 2 periods long, we can either continue it to the right or copy it to the left, just reflect it over that x-axis or y-axis there. But where are my vertical asymptotes going to go for this one? Pi and 3 pi. So I'm going to go ahead and plot my vertical asymptotes on there. And then when I actually graph the secant function, I'm going to graph that in blue. I start at my maximum and minimum points, and I just draw my parabolas. And it's not quite a parabola, but it is a U-shaped function that you're going to have up there. Okay? And this is exactly 1 period long. If I would continue it, this parabola would obviously continue over here on this side and continue over here on that side. All right, this next one here, we're graphing a cosecant. Cosecant is the reciprocal of what function? Sine. So what I want you guys to do right now is go ahead and graph your sine function, and if you feel confident, you can graph your cosecant function as well. But start out with filling out your XY chart and apply all of the transformations that are occurring in there, and then try and graph it. Okay, so all of my, let's see, values here should be 0, 1, 0, -1, 0. First shift that's happening is this vertical shift, not vertical shift, but a stretch of 3/2. So I'm going to multiply all those by 3/2. And then this minus pi over 2 is going to shift my graph which direction? Pi over 2? Right, pi over 2. Okay, so multiplying by 3/2 would give me 0, 3/2, 0, -3/2, and 0. Shifting it right 2 for my x's is just going to add pi over 2 to my x's, so this becomes pi over 2. So these are all just going to shift over 1, and then leave us with 5 pi over 2. Okay, so I can go ahead and graph my sine function on here. So sine I'll do in red. So I'm going to start not at 0, 0, but at pi over 2. And label all of my values. And then I'm going up to 1.5. So I'm going to label this 1 and that 2. So I'll go in between those. If you also just put 1.5 at a point, that's fine too. And then I can go ahead and plot this. We're starting at 0, 0 here. Well, actually, pi over 2, 0. And then, oh wait, no. Yeah, we're doing sine. Yep, so we're going up. And then back down. And then down again, and then back up. So here is my sine function that I'm going to use to help me guide where my reciprocal cosecant function is going to go. So my vertical asymptotes are exactly where my values are going to equal 0. So that's going to be at pi over 2. So I'm going to have a vertical asymptote at pi over 2. at 3 pi over 2 and at 5 pi over 2. One thing to note is your vertical asymptotes are always where your midline is equal to, or sorry, where your points are on your midline, right? So like right here is my x-axis and my midline because it's the same distance from here to my maximum and minimum point, so like my amplitude. But that could be shifted up or down, okay? So just keep that in mind. And then when I go ahead and draw my cosecant function in here, I'm just going to take my maximum and minimum points and draw my U-shaped parabola in both of those places. And that is it. Questions on that one?
I got some.
Yeah, no, that should be 4 pi over 2, which equals 2 pi. So, good catch. Any other questions up there? Okay, then the next part, we're going to be given a graph and we have to write an equation. Okay, so let's take a minute and look at example 3. I'm going to give you guys a minute or two. I just want you to totally try something out. Like pull up Desmos and just try graphing different things. It's going to be either a cosecant or a secant graph, but see if you can make it look like this. Okay. So on these ones, it's a little tricky because like they look the same, right? Same thing with like sine and cosine. So we need to draw our kind of guiding function in there to start. Okay, so I'm going to choose blue color here, and I'm going to connect these points. Okay, when I connect these points, oops, not exactly perfect, but that's actually one full period length. And what does that actually look like? Is it a secant, or sorry, is it a sine or a cosine function, that blue one? It looks like a cosine function, right? Because we're starting on the y-axis up on 0, 3. Okay, we're not starting at 0, 0 for sine. Another thing that you can kind of notice, remember for a cosecant or secant function, if it's one period long, it needs to have 2 full parabolas. So if I look at just this distance between 0 and this pi over 2 point, okay, I have 1 full parabola down here, and then I have half of a parabola and half of a parabola. So that's 2 full parabolas, right? Okay, so therefore I know that we have 1 full period. So again, same thing with sine and cosine. Technically there are 2 correct answers here because they're just shifted horizontally of each other. I would prefer you to do the one that is a little easier without that phase shift if possible. Like for this one, this is a cosine function for your reciprocal. So cosine is going to give us our reciprocal function of secant. So this is actually a secant function. So I know it's going to be y equals secant of something. Now another thing that's being changed or different is the distance between where your curves happen and your x-axis. What do we call that distance between your maximum or minimum point and your midline? Your amplitude. So my amplitude in this case is what? 3. So my amplitude is 3. So that means I'm going to put a 3 in front of the secant. And then the only other thing that changed is my period length. My period length goes from 0 and it ends at what x value? Pi over 2, right? So if I go from 0 to pi over 2, that means my period length is 2 pi, or sorry, pi over 2. So I need to set up this formula. 2 pi over b is equal to pi over 2, and we need to solve this. So if I cross multiply, I get 4 pi is equal to b times pi, which means that b is equal to 4. So my equation is going to be y equals 3 times secant of 4x. There was no phase shift, there was no vertical shift, and I know there was no vertical shift because from this midline, which is usually our x-axis, it's the same distance to my maximum and my minimum points. Sorry, I can't talk. Okay? Questions on that one? Okay. Example 4. Give you a pretty good guess here of what you think this one's going to be. If this first one was secant. It's going to be cosecant, okay? So, again, let's start out by drawing in my guiding function, okay? So if I connect all of these, points here, let me choose a different color. Let's do red this time. If I would connect all these points, this is my guiding function there. Which means, where is my midline? My midline is normally on the x-axis, but in this case, it does not look to be. Where is my midline shifted to? Down to where? Down to -4, right? So down here at -4, that is my new midline. Okay, which means we're going to have a vertical shift down 4. So with my function, we're still figuring out what it is, but it's going to have a -4 at the end of it because we're shifting that all down 4. Okay, and then I'd always start on the y-axis. Okay, looking at the y-axis and where my midline intersect, this point right here is like our new 0, 0, right? Because our midline has been shifted, okay? So if I start at this point and then go down to this point, back up to this point, up to this point, and then back down, those 5 points right there make what kind of curve? Sine or cosine? It's a sine curve, but it's a special sine curve because what's happened? It's not stretched, actually. Well, actually, yeah, no, it's not stretched. It's upside down, right? This whole thing should be flipped, okay? Because normally your sine function looks like this, right? But instead it's opposite. So it's a sine of x function and it's reflected. The reflected piece tells me we're going to have what where? A negative in front. The sine piece tells me, okay, well, what's the reciprocal of sine? That's the function it's going to be. Reciprocal of sine is cosecant. Okay, so this is negative cosecant of x. And then we just need to double check our period length. Okay, my period length of those 5 dots that I just drew, if I kind of just highlight that area there. Okay, we've got my 2 full parabolas for my cosecant or my secant graph, depending on what we've got. And I'm starting my x-axis, we're starting at 0, and we're going all the way to this 3 pi over 2 negative 3 point. That's actually right here. So then this value is actually going to be 4 pi over 2, which is just 2 pi. So I go from 0 to 2 pi, so my period is a length of 2 pi, which means your b value is just 1. So I don't need a number in front of that x-axis because my period has not changed. It hasn't been stretched, it hasn't been shrunk. And so I do believe, unless I've forgotten something up there, that should be your answer for that graph. So negative cosecant of x minus 4. Questions? Okay, this stuff can be really tricky, so make sure the homework is only front and back. Okay, so please make sure you are working on that. I will give you guys a little 5-minute break here though, and then hopefully you can get a good chunk of that homework done in class. Okay.